Hey guys, this video is going to be about neutralization reactions and titration. So we're going to start with neutralization reactions. Now some of this will be familiar from when you were predicting products at the beginning of the semester. So first off, a neutralization reaction is a reaction where an acid and a base react together to create a neutral product. Okay, so our neutral product is always going to end up with being water and a salt. Now salt doesn't always necessarily mean it is NaCl. Salt in this sense is any ionic compound. And the important thing when you predict your product and make your salt is that you always drop and swap. You find the charges from the periodic table and you drop and swap to make your products. Okay, because this is a form of a double replacement reaction because you have two ionic compounds mixing and producing, swapping ions and producing two compounds at the end. Okay, so when we predict the products, what we want to do is we want to remember that the outside ions go together and the inside ions go together. So the H plus and the OH minus is always going to make water. So it's always going to end up being H2O. And then your other ions, you have to drop and swap. So an Na has a +1 charge and a chlorine has a -1 charge. You always want to write the metal first. So then you would end up being NaCl. All right, the metal always gets written first. So again, when you make your products, it's always the outside ions together and the inside ions together. And it doesn't matter that this is a 2 and this is a 2, it's always going to make water. Okay, those 2's will end up balancing out when we actually balance the chemical reaction. Okay, you always put the metal first. So what's the charge on barium? Barium has a +2 charge. What's the charge on sulfate? SO4, 2-. So barium sulfate would be written as BaSO4. Then we would go back and balance the reaction by putting a 2 in front of our water. Okay. All right, so doing this kind of practice here, again, the outside ions go together, the inside ions go together. So when you combine barium, which has a +2 charge, my bad, +2 charge, and phosphate, which has a -3 charge, and you drop and swap, that's going to end up being Ba3PO4 2. Plus, what does the H and the OH make? Water. Again, it doesn't matter what these numbers down here are. You do not bring the numbers. You do not bring the subscripts. Those are there because of the dropping and swapping that took place on the reactant side. Okay, I'm not going to balance the reactions just for the sake of time that it would take for the video. So you guys should know how to balance already. If you don't, get with your teacher. All right, down here, again, your outside ions go together, your inside ions go together. It doesn't matter which one over here you write first. If you write the water first, if you write the salt first, it doesn't matter. So we're making water, H2O, and salt, Na has a +1 charge. Acetate, C2H3O2 has a -1 charge. The metal gets written first. So when you drop and swap, that becomes NaC2H3O2. Outside ions go together, inside ions go together. So we make water, and K has a +1 charge, sulfate has a -2 charge. The metal, the positive ion, gets written first, so it's K2. That 2 is from the sulfate, SO4. And then last one, outside ions go together, inside ions go together. So you're making water, and sodium has a +1 charge, carbonate has a -2 charge. So we're making Na2CO3. All right. So things to remember: the acid and the base, if you're reacting, acid has a hydrogen in the front, base in these cases for neutralization reactions are going to have a hydroxide ion. It's going to make salt and water. So neutralization reactions pop up in everyday life. We put a picture of soil up here because soil, we can have acidic soil, you can have basic soil. There's different products that you can buy at the store to make your soil be more neutral to enhance plant growth. Anytime you have an upset stomach or heartburn or anything like that, any of these over-counter products, Tums, Alka-Seltzer, Pepto-Bismol, they're designed to neutralize that stomach acid that comes up into your esophagus and everything. So all of those products, Tums, Alka-Seltzer, Pepto-Bismol, they have bases in them. And so when you add it to it, it would neutralize that stomach acid and soothe that, you know, pain and indigestion that you have. Toothpaste, and you brush your teeth, that's actually also a neutralization reaction. A lot of the foods that we eat and drink have acids in them. A lot of our citric foods, coffee, sodas, that kind of thing, they're all acidic. And so when we brush our teeth, it neutralizes the acid that gets stuck on our teeth from the eating. So before you go on, or at some point, make sure you do practices 1 through 10 on page 11 to 12 in your packet. Now, titrations, this is a method that we use to neutralize an acid or a base. So we use these titrations to do a neutralization reaction so that we can figure out what the concentration of an unknown substance is. So what you'll do is you'll put some kind of acid or base in here. Okay, it doesn't matter. This says it's a titration of an acid with a base. So that means that the acid is down here. You put the opposite in the burette, okay? And so the thing that goes in the burette has a known concentration, and we're gonna know how much we put into the acid because we're measuring how much we're putting into it. We know how much acid we put into our container in the first place. So you would slowly add whatever's in the burette, in this case it would be a base, we slowly add that into our flask until we see a color change. The color change is because of an indicator that we're using. The indicators change colors at certain pH ranges. And so when we see that color change, we know that we've hit that end point, that pH change from the acid to the base, okay? You'll be doing a titration virtually in order to practice this skill. So again, what you're going to be doing in your titration, you would be putting a specified volume into the flask. That flask goes underneath the burette. We know how much we have. We don't know the concentration of that substance. That's what we're trying to figure out. An indicator goes into the flask as well, so that way it'll change color when you've added enough of the base or enough of the acid, depending on what you're doing. You fill your burette with known concentration of a substance, because we have to know what concentration we're using and how much of it we're using to figure out what the unknown concentration is. You slowly add it until you see a color change. It says light pink here because in the picture it was using phenolphthalein. The color change will depend on which indicator is being used. So in this case, you can see that some acid was in the flask down here, base was in the burette, and the color change is indicating when the endpoint has been reached, when the pH change has happened. We want the faintest color change possible because we don't want to over titrate. We don't want to add too much because then our calculated molarity will be off. So when we determine the concentration of a substance, we use the formula MAVA equals MBVB. And this might look familiar from the solutions unit, when we did the dilutions calculation, which was M1V1 equals M2V2. So it's the same thing. The A is representing acid, the B is representing base. So in this question here, it says we started with 20 milliliters of an unknown acid. So that's our VA. Let me draw this here. So that's our VA. Added 6.5 milliliters, so that's our VB of NaOH, because NaOH is a base, and this is the concentration, the molarity of our base. And we're trying to find the concentration of our acid. So we're trying to find the molarity of our acid. We know that the volume of our acid is 20.0 milliliters. We know that the molarity of our base is 6.00 molar. and we're using 6.50 milliliters. You can keep it in milliliters as long as you have milliliters on both sides. So in order to solve for the molarity of our acid, we're going to take our 6 times 6.50, and we're going to divide that by 20 to get the molarity of the acid by itself. And we should have 3 sig figs, so we should have 1.95 molar solution of the acid. So again, how many milliliters of 0.4 molar hydrochloric acid have to be added to 25 milliliters of a 1 molar solution of a base? So this is the molarity of our acid. This is the volume of the base. You have to make sure you read carefully. Just because it's the first volume that's listed doesn't mean it goes with the HCl. It goes with the KOH. And this is the molarity of our base. So this time we're solving for the volume of our acid. So Ma, Va, so that's our unknown, is equal to Mb, 1.00 molar, times Vb, 25.0 milliliters. So to get the X by itself, we would take 1 times 25 divided by 0.45. We would have to add about 56, because of sig figs, milliliters of acid into that solution to get it to neutralize. Down here, how concentrated, so that means we're looking for molarity, is a solution of HNO3 is at an acid or a base, that's our acid. If 3.55 milliliters, so that's the volume of our acid, is used to neutralize 11.65 milliliters of 0.5 molar KOH. I know that's a base because OH signifies the base. So Ma, we're looking for Ma, times the volume, 3.55 milliliters, equals the molarity of our base, 0.50 molar, and the volume of our base, 11.65 milliliters. So I take 0.5 times 11.65 divided by 3.55 to solve for X. X is your molarity of your acid, remember, and that's going to be 1.6 molar HNO3. Okay, titration curves. The titration that you guys are going to be doing is going to have you guys take a look at that titration curve. One thing it's going to show you, this is basically about what's in the flask. It's a titration curve of what's in the flask. So when it starts down here, that means that you're starting with an acid and you're titrating it with a base because you're going from a low pH acid to a high pH base. This one, what's in the flask, has a high pH, so that means you're starting with a base in the flask, you're titrating it with acid, which is why you end up with a low pH. The equivalence point, that's like halfway up your curve. That's indicating the point at which your hydrogen ions are going to equal your hydroxide ions. So we're just going to be doing strong acids and strong bases, which means that your equivalent point should have a pH of 7, because that's when your H plus and your OH minus are equal. The end point, that's when the actual titration that you're performing is going to change colors, and you'll see that color change indicating that the neutralization reaction has occurred. All right, so you're going to do practice 1 through 5 on page 13, and then you are going to do the titration practice that is in your Google Classroom. So just let us know if you guys have any questions, and we'll be happy to help.